Hello, everyone. Today we're going to talk about governance in distributed systems, distributed event-driven systems. So I try to dive into my experience and share some of failed but golden experiences that I had. So hoping you will put enough engineering and pragmatic guardrails in your design journey and your event-driven distributed event-driven adoption. So first, I introduce myself. My name is Omid, and I'm a solution architect at Groupe Centrale, also an AWS community builder, but also author of Mastering Serverless Computing with AWS Lambda. I share you my social network links, and I will be happy to connect with anyone. Also, if you're interested about serverless, event-driven design, and distributed systems, I post regularly on my website, serverlessforks.com. So let's go. Distributed systems are hard, and I would like to say they are really hard. If anyone can convince me that they are not hard, I'm open to listen and to learn from the others. But actually, my message is that designing systems need vigilance. So what I mean by vigilance is natural vigilance and experimental vigilance. The natural vigilance is kind of when a car is driving toward you. So being a baby, a child, or an adult, you will reflect. It's great that you're naturally aware of something. But experimental vigilance is in digital world. In digital world, there is natural vigilance. There is no natural vigilance. So we learn from our past. Oh, but how we can now all those details to uh, to think about and analyze them. So in digital world, we listen to others. We learn from other experiences and or proper experiences and proper bottlenecks. We analyze them and we try later to put enough guardrails in our way to don't jump in the trap. So my history starts about less than 2 decades ago when I was a software engineer in a small team, but 4 persons, 5 persons, and we was collaborating in an open space at work with 7 other teams to design and develop a multi-system with a single database, a single piece of software, a single piece of code with some complexities, but collaboratively, we had no problem. We had the same language, we had the same level of expertise in our business domain. We developed things, and for sure, we had some consumers. Web application, letting our engineers on site to use that application to simplify their life, their daily work. At the end, we was improving our observability system. So we asked some vendors to send us back the metrics that they are gathering from our system or infrastructure to our system. What's happened here? We had the first vendors, the second one, and third one, and some level we wasn't able to scale. The scaling became a bottleneck with 3 dedicated server into 3 dedicated data center on-premise data centers with a single mirrored database. But we wasn't able to scale. We was propagating the errors. But actually, when we was debugging our problems, we knew that we are in the compute side or in the database side. And actually, we knew when we are done, all consumers are struggling from those errors. We started to resolve our scaling problems. So we adopted distributed systems. We added some layer of communication in our communication chains via asynchronous APIs. So now a request was passing different nodes in distributed chain communication chain to achieve the service at the right and bring back the responses to the consumer, to the communication connection initiator, the requester. When something was down, either be at the end of the communication or in the middle, the request was failed. So we was again propagating the failures. So we started to look at the technical solution, the conceptual solutions. With one distributed microservices can be a solution. So we learned at the microservices. We learned that a microservice is a service with predefined responsibilities and do something well. But also, it was fascinating that we discovered that we can provide all necessary communication interfaces, being synchronous APIs, being brokers, being event bus, being channels, communication channels. We was able to communicate our asynchronous messaging. So we adopted asynchronous messaging in our distributed system. So we had mostly event-driven communication, but at some point we had some API usage, synchronous communication. We discovered that we can scale. We're not propagating the errors, but when some services in the middle of that communication line are not able to respond, or they are experimenting some downtime, some temporal downtime, we discovered that we achieve inconsistency. So we have two levels of consistency: at the right, strongly consistent, and at the left, consistent, and at the right, inconsistency. We tried to look at this problem, but at some level, this was a long journey. We stopped looking at technical solutions. We started to list our problems. So state inconsistency was one of the problems that we discovered in distributed and event-driven architecture. Coordination difficulties. In a localized scenario, when I said we had no problem to communicate, we had the same language, the same level of business domain vision, and we had the same language. But when you go over distributed system, we introduce naturally the silos. So the different teams that are responsible for different things, and they have different arguments, different vocabularies. So that ownership, that silos, brings some challenges in your communication. Lack of observability. We was able to keep track of failures at the compute level or at the service level, at the component level, but what's happening in the overall system? The quality bottlenecks. We try to think about testing quality. Unit tests are great, but in distributed system, those are not enough. The interesting part will be the integration testing, end-to-end testing. But as we had a distributed mesh of services, distributed component was a lot of distributed component. We had a lot of lines. So what is the pretty one? Where can I put the effort? It was frustrating. So we decided to look at the process workflow and apply some end-to-end testing. But actually, it was working, but it was against microservice and distributed component autonomy. So either with those tests, we wasn't able to withdraw release or single components. So we started to looking at the root cause of problem. We dived into the details of any module and any component and any line. And after some analysis, we discovered that we have two kind of communication. Some communication are related to the same context. So we put a line, a box around them, and we introduce internal and external communication. So we put all our effort to guarantee and assure the quality of external communication between those bonded contexts. External POP/SOP, S-Stream, queues, or API gateway adapters. So we had different kind of gates. So we put our effort to apply quality check, and integration testing at those layers. But to start our journey, when we was trying to structure and shape our journey, so we started to ask what we need to achieve, accelerating the rate of changes. So to accelerate our rate of changes, we was adopting the contract quality and defining the contracts. For sure, the contracts was trying to be documented, but we wasn't it wasn't so cool to put side up but frustration in distributed systems, a distributed documentation. So we started to give the notion of catalog. So we had the central catalog that follows all the life cycle of all services, all contracts, being internal, being external, but separated to simplify the people and software communication. As we talk about governance, I would like to mention that the governance to me has three pillars: standards, path, and tooling. Why I put these three pillars in my governance as the important pillars of my governance. What, as a citizen, I ask the government is law, education, and services. So it's easy: standard, golden paths, and tooling. This is what I ask. As we are talking about event-driven, let's define what is a message. A message in asynchronous messaging can be a command: do me a favor, event, I did your favor, the favor that you asked me, and this is the results, or related records or streams. If you look at this diagram, the command, the events are attached or decorating the communication lines and not inside the producer or client box. What is important in event-driven architecture is it's in communication pattern. So these are decorator over the lines and not inside the boxes. So jumping in the standards, when I talk about standard in event-driven architecture, I put this envelope on the screen. So this is a letter coming to me in France from Hong Kong for my anniversary. It's a gift. It's confidential, international, and a tracking number on it. For sure, sender and destination as an interest actor. But who is interested to look at inside that envelope? It's the destination. When you put the technical standards like cloud events specification side of my example, we have the contextual metadata that are used for transition and routing. The postman is interested about the international label to put it in an international box, not into the local box. And these metadata are used for transiting that letter from the sender to destination. But we have for sure the letter being a data payload, but it's dedicated to the processing side. So we need to separate these two concepts. I don't want to jump into all standards, but try to adopt a community standards. Those standards are challenged in a wider community than your enterprise, because your problem maybe was the problem of others. So a sync API, open API, close events are as to define some kind of workflows. When you order products, so you have the payment service communication, warehouse product service communication to the end to validate that order. X registry kind of foundation to have a catalog of all events, all consumers, all producers of those events. Golden paths. When we talk about golden path, this is the educational part of any enterprise. We have different level of expertise in the enterprise. So at some level, we need to document and highlight the hidden part of any provided community documentation. We talk about fanout, we can publish subscribe patterns, but actually we never dive into the, the excellence pillar of these patterns. A publish subscribe pattern must be indicated as a real-time distribution on event. In a distributed system, and as you are at risk of inconsistency, decreasing the number of nodes between a producer and a consumer and reducing the timing gap is just give you a chance to be more consistent. Depending when you provide a channel, a broker, a queue, letting your requester send you some kind of commands. So here we use a single infrastructure. In process, we look at those events and we trigger the dedicated workflow behind any type of events. As streaming, streaming is one of the greatest event-driven solutions for analytics and real-time big data processing. But the trick here is that it's a poll-based, naturally, it's a poll-based solution. So a consumer as it's polling can impact the others. But why? Because no streaming, the streaming internals push us to have the persistent managing the ordering, managing the estates, managing the partitions. So for these reasons, there are limits. There is no streaming broker that is really indefinitively go to beyond the real scenarios. So you need to control who is a consumer of this stream and leverage and choose the best consumer that really need those streaming broker. Request reply. In request reply, the challenge is that you introduce two layer of dependency. If they are hard dependencies, it means both components are coupled to other, and this is not a real problem when you go incrementally. But if one day I say your zone, your availability zone, your region is down, deploy all your system in other region, you are not able because the box at the left depends on the box at the right, and the box at the right depends on the box at the left. So you need to try to benefit from all technical details, being CPU resources, processors, memory, threads, also the infrastructure, and try to, in this situation, lighten the heavy dependency. You can provide some level of return address pattern and kind of this stuff to let you leverage this coupling, this heavy coupling. As I mentioned, when you have thousands of distributed system at some rate, you're no more able to put the efforts to optimize your distributed system. But you can define the boundaries, the bounded context to simplify your revolution or your optimization journey. You can adopt the patterns like event match. This led you centrally connect the buses, the channel, the topics together. So infrastructure can be based on the role interested actor of another channel or another bus on another broker. This way, in a managed manner, you will connect different bonded contexts, and you will have a clean design till you can clean up all your internal complexities. And tooling, this is the shortest part of this talk. And here just I want to show you the categories of tooling. What are the services that your engineering teams and your engineers need? The blueprint. The blueprint is concrete guidelines that represent a use case. So that can be kind of examples or really industrialized solutions. Observability tooling. You need to provide enough observability tooling, but accomplish the goal to prepare the foundation for observability. And development tools to let your engineers work on local environment, equality and security analysis, providing some kind of SDKs. SDKs are important, but in a pragmatic manner. Leave the technical details evident, but abstract them to simplify adoption. Automation tools, testing tools, collaboration tools. This is one of the most important pillars because you need to, while you talk about collaboration, you need to think about system and people collaboration. So provide enough collaboration support to let your systems and your people shake hands and work together. And experimentation. As the technology evolves, we need to let our teams experiment new things. Experimentation, tooling, and providing a way to experiment new things for your CTO, for your architect, for your leaders, for your software engineers, or for your product staff is important. Being in local environment, dev environment, staging, or production. Whatever is your choice, put enough support, enough facilities to simplify the experimentation phase. Hope I could help you, and thanks for attending and for listening to me. Thanks.